Section 2.3, Solving Inequalities Using Multiplication or Division. This is going to be an extension of what we looked at before with solving inequalities using addition and subtraction. Multiplication and division is very similar, but there's one important thing that's going to change. Let's take a look first at just some basic inequalities. Here I have 2 is less than 7, which is a true inequality. I could see that on a number line, I could pretty easily put a 2 and a 7, and that shows that 2 is to the left of 7, which on a number line means that 2 is in fact less than 7. So, okay, that's pretty self-explanatory. And as a matter of fact, if I actually take each side of this and double it, 2 times 2 is 4, 7 times 2 is 14, I'll get another inequality that's also true. Here's 4, and here's 14, and once again, 4 is to the left of 14, which means 4 is less than 14. So if I have an inequality and I double each side, it's still going to be true. In fact, if I take my original inequality and I divide by 2, cut it in half, 2 divided by 2 is 1, 7 divided by 2 is 3.5. Once again, I have a true inequality. I have 1, I have 3.5 on a number line, and once again, 1 is to the left of 3.5, and so it's a true inequality. But that's been when I've multiplied by 2 or divided by 2. Something changes if I multiply by negative 2. Take my original and multiply each side by negative 2, and I get 2 times negative 2 is negative 4, 7 times negative 2 is negative 14. Now on a number line, I see that negative 14 would go here, negative 4 would go to the right. So, negative 4 is on the right. That means that negative 4 is actually greater than negative 14. So when I multiplied each side of my inequality by a negative number, in this case negative 2, I started with a less than, and it became a greater than. This is an important thing to keep in mind. This is going to be the main thing that's new about this section. It comes from the fact that when a number is bigger as a positive number, it gets smaller as a negative number. 14 is bigger than 4, but negative 14 is smaller than negative 4. The bigger the negative, the smaller the number actually is. That's going to be the big key for what we're going to look at today. Okay, let's start off with the easy ones, working with positive coefficients. What I'm going to do here is I'm going to look at this, I'm going to try to isolate x each time. And it's going to be pretty straightforward. For the first one, I have 5x is greater than 15. 5x means 5 times x, so I want to divide each side by 5. When I do that, I just get x is greater than 3. Nothing too fancy there. And then on the number line, it's just greater than, so an open circle, and greater than goes to the right. I can pick a test value over there, and I'll see that it will work out. I can test that out. Next example, y divided by 6 is greater than or equal to 2. Y divided by 6, got to cancel that out. Got to multiply each side by 6. In so doing, I get y is greater than or equal to 2 times 6 is 12. That's pretty straightforward, as I said. Plot the 12 with a closed circle because I have the or equal to, and I have to go off to the right. Gets a little tricky here when we have a fraction, but there's a simple way to do it. If we're having 2/5 z, that means 2/5 times z. So we need to divide by 2/5, but the alternative to dividing by a fraction is to multiply by its reciprocal. So I'm going to multiply by 5 over 2. Actually, I'm going to write this right next to the 5 so it's a little bit easier for me to see. And when I do that, it's often easiest to put that over 1. That way it'll remind me how to multiply. I'll be left with the z is less than or equal to, now 5 times 5 is 25, and 1 times 2 is 2, so 25 halves. You can leave it like that, you can make it 12 and 1/2, you can make it 12.5, any of those are fine. I'll put it as 12.5 here, just to make it a little into a decimal. Closed circle, because I'm including it because of the or equal to. And then I want z to be less than that, so I come off to the left. Simple as that. Fourth example here, just to cover another inequality. 1.2w is less than 3.6. That means 1.2 times w, so I'm going to divide each side by 1.2. And it states w is less than 3.6 divided by 1.2 actually works out pretty nicely. It's just 3. It's basically the same thing as doing 36 divided by 12, so that's pretty convenient. And I'll go to 3, open circle. I'm not including 3 there. It's not part of my answers. And everything less than that comes over here to the left. All right, so those are really straightforward. If there's a positive coefficient, you just isolate the x by using inverse operations, and you're good to go. Then you just graph your solution. All right, what happens when we have negative coefficients? So when we have negative coefficients, we do it the exact same way, but we have to make sure we flip the inequality. Greater thans become less thans, and vice versa. For my first example here, I have negative 3a is greater than or equal to 12. So when I divide each side by negative 3, I'm going to get a, I'm going to get negative 4, and this is where I need to make sure I flip the inequality. That's a greater than or equal to, it becomes a less than or equal to. And that's because I divided by a negative 3 on each side. That's the big important piece. So then to graph it, I just go to negative 4, close in the circle because of the or equal to, and I'm coming over here to the left. So I'm talking about these negative numbers over here. You could check this certainly and plug it in, and they all should work. If I pick, say, negative 5 and plugged in negative 3 times negative 5 is 15, and 15 is greater than 12. So that works. All right, next one. B, that's an over or divided by negative 4 is less than negative 7. So when that's the case, I'm going to multiply by negative 4. And I'll get B. Now I multiplied each side by a negative, so I flip the inequality. And then negative 7 times negative 4 gives me 28. Negative times negative is positive. But it's become a greater than now, so I go to 28, open circle at 28, and over to the right to show greater than. Again, it doesn't matter what this number is. This was negative, this was positive. We flipped the inequality both times because of what we're dividing or multiplying by on each side. That's the big key. All right, another example with fractions. Once again, I'm going to multiply by the reciprocal of the fraction, so I'm going to multiply by negative 5/3, and I'll write that right over here. So that'll leave me with C. I multiplied each side by a negative, so I flip the inequality once again. And then negative 5 times 7 is negative 35, and 3 times, let's fix up that 5. That's a little ugly there. And then 3 times 3 is 9. Now that doesn't reduce. It's negative 35. You could have that be negative 3 and 8/9, negative 3.8 repeating. Whatever works. There's no reason we can't just leave it as the fraction as well. So we have negative 35/9, and we want things less than that. So an open circle, and we're coming off to the left. Again, we flipped the inequality because we multiplied each side by a negative. Same thing with the last example. I'm going to do d divided by negative 2.2 is less than or equal to 3.5. I'm going to take care of that by multiplying each side by negative 2.2. Now let's give ourselves a little bit of room so we can remind ourselves how to do this multiplication here. And I know that I'm going to end up getting a certain piece, and I'm going to have d flip the inequality greater than or equal to, and I'm going to have a negative. But I do need to make sure I do the multiplication correct. So if I don't have a calculator, I want to make sure I do it out correctly here. I'm going to do 2 times 5 is 10. And then 2 times 3 is 6, plus the 1 is 7. And I'll leave myself a space here. And 2 times 5 is again 10. So that 1 actually is just going to end up back up on top. And then 2 times 3 is 6, plus 1 is 7. and then adding straight down, I get 7, 7, 0, and I have to think about where I put that decimal point, and I think it's going to be actually right between the 7 and the 7, because I need 2 decimal points there. So I've got 7.7 is, oops, didn't mean to move that around. Negative 7.7 is my my value. A little calculation there gets us. And negative 7.7. Now I want the numbers that are greater than or equal to negative 7.7, so I'll close circle, and greater than's to the right. And that's all we need. That's all we have to do. So hopefully this makes some sense. Doesn't seem like it should be too bad. Alright, so Mr. Callan is planning a little trip, just a little short ride. He's going to drive from Algonquin straight to Disney World this weekend. And ideally, he'd like to arrive in under 20 hours. So the question is, what speed must he average to complete the 1,280-mile trip while meeting his goal? Of course, when he goes to Disney World, he'll be doing this this work with Donald and Huey, Dewey, and Louie, as you can see on the chalkboard. So what this is about, this is actually, it may seem kind of easy to do, but we can think about this in terms of inequalities. And so we're going to use the fact that distance equals rate times time. That's going to be our first key point here. And we know the distance here, 12,280, and we don't know what the rate is. And we do know that he wants to do it in a certain amount of time. Now, what we're hoping is we have to know what speed he has to maintain. So we're hoping that we can go a particular speed for 20 hours, and then we'll get to Disney. So we have to get at least the 1,280 miles. So we're actually going to here have that this is less than or equal to r times 20, because we need to make sure we go that entire distance. If we are able to drive faster than that, it doesn't mean we'll drive past Disney World. It means we'd stop, but we'll have gotten there in the amount of time that we needed to. So anyways, now that we have this, it's a simple inequality to solve because they don't have any negatives. And so I just divide each side by 20, and that's actually a pretty easy calculation to do. It works out rather nicely. What it says is that 64 is less than or equal to r. Well, I want to make sure I put this back into context. And so I'm talking about a speed here, and so what this really means is that I have to be going at least 64 miles per hour on average. And so if that's going to be my average speed, that's good because I would certainly never exceed the speed limit, which on the highway that I'll be on for most of this would be 65 miles per hour. So it looks like I should be able to make the trip on time, and if there was no speed limit, going at 70 miles per hour or 80 miles per hour would also get me there in under 20 hours. And then I would probably just stop when I got to Disney World and spend some more time there. All right, there's a good example for you. All right, go ahead and give these a try and then come back and check your work. Let's see how you did. All right, so there you go. Check your work and make sure on the bottom two that you flipped your inequality because you multiplied or divided sides by a negative. And there you go. Nice work.